right, this is going to be Unit 5, Lesson 3. All right, we are looking at logarithms as inverses. Okay, so first off, I have our warm up. Um, if you want to turn to page 37. Okay, Han purchases a computer for $600. The value of the computer over time is represented by f of t, where t is the time in years. And Han wants to sell the computer when it is worth $400. When should Han sell the computer? So when we actually look, we see that here 600 is where it starts, and that's where our y-intercept is right here. All right. And then it kind of keeps going down, which makes sense because this is 0.8, which is less than 1. So it's decreasing. Well, we want to know, when's this value going to be 400? Okay, so I go here and I see where it crosses. So somewhere in between 1 and 2. All right, right there. So where it crosses. We can estimate that. However, we can also find that exactly. All right, it's when this equals. All right, so 0.8 to the t. All right, so what I'm going to do is I'm going to go to Desmos right quick. All right, and I'm going to plug it in. I'm going to put in 600. All right, 0.8. Don't raise it to the t, raise it to the x. All right, and then 400. Don't put just 400. You got to put y equals 400. All right, now we don't see anything. So what I'm going to do is I'm going to zoom out. I'm just using my fingers to zoom out. And if you think of it, it's got to be 400. Now you're going to want to zoom right back in because we don't want to get this y-intercept right here. We want to get this x-intercept where they cross. And it is. It was in between 1 and 2. So it's exactly at 1.817. 1.817. All right. So let me go back. All right. And when I'm doing this, all right, here, if we look, this is the value of the computer. Okay. And this is time in years. So this is going to be at 1.817 years. All right, so let's do it again. This time we have Elena starts posting lacrosse videos online. She has 10 followers to be in it with. One of her videos goes viral. The number of people that follow Elena on social media is given by the rule G of D. And we see that right here. Start off with 10 people. And then it looks like, what is she doing right here? What does this mean? What does the 2 mean? It means that it doubles. Okay, so it's doubling each time. All right. How long will it take her to reach 1,000 followers? So this time it's growing. All right. So we want to know, this is the number of followers right here. We want to know, when's this going to equal 1,000? Well, here it looks like it's in between 6 and 7. Well, to get that, we're going to set 1,000 equal to 10 times 2 to the d. All right. Now, we're going to look at solving these by hand, but we can also solve them on the calculator. All right. So if I go back to Desmos and I put in, let's clear this out, 10 times 2 raised to the x. Don't put d in there, just put x. And we want to know when this equals 1,000. Now, make sure you put 1,000, not 100. Okay. Now, I'm going to have to really go up because 1,000's way, way, way up there. And now I see that line. Now, again, like we did last time, we're going to want to zoom in, which I'm having trouble zooming in right there. Whoops, that zoom out. Okay, so like right here, just make sure you're not getting the y-intercept, okay, which I'm not. Okay, you're getting the x-intercept. So, or not x-intercept, you're getting where the 2 intersect, and it's 6.644. So how long will it take for Elena to have 1,000 followers? All right. And if we go back to the problem, it's in days right here. So it's going to take 6.644 days. All right. And we have one more right here. If you want to pause it and do it on your own, feel free to. Okay. Tyler is headed to college in the fall. They have a full scholarship for tuition. They take out $450 loan for books. The bank charges 18% annual interest on the loan. Okay, the amount Tyler owes is given by H of T, where T is in years. How long will it take for the amount Tyler owes to double? Now, this one's a little bit different because the last two, it gave us the 2 values it was supposed to equal. But here we want to know, how much will it take the account to double? Well, what did it start with? Started with 450. So if we're going to double it, 450 times 2, is 900. We want to know, when is this going to equal 900? We also see right here where they did 1 plus in that 18%, so 0.18. All right, so here we're looking at, there we go. It's a little clearer now. Okay, we want to know 900. 900 is somewhere right in here. Okay, so somewhere in between 4 and 5. But let's see if we can go find that exactly. All right, so again on Desmos. All right, let's put this in 450. All right, 1.18 raised to the, don't forget to put X, whatever variable they have there, T, don't put it. Okay, and Y equals 900. All right, so here, anytime it says they want to double, think about what you started off with. All right. Whoops, hold on. I was trying to share something else. All right, here I gotta go find the intersection. Okay, and again, you're going up here to 900, so I gotta go up to 900. All right, I'm gonna see, let's see, there we go. Make sure you're not getting the y-intercept. I don't care about this one. Y-intercept is when the x is 0, by the way. I want this one right here, 4.188. All right, and so let me go back and we'll see what this is in and what the question was asking. It said, how long will it take for the amount to double? If we go here, it says it's in years. Okay, so it's going to take this many years for it to double if it's at 18%. All right, so make sure you know how to solve problems. Make sure you can plug things in. And we're going to be working on using something called logs here, okay, to solve these in a second. But you saw that we can actually solve these all using the calculator. All right, so let's move on. Okay, here's our notes for today. Unit 5, Day 3, logarithms as inverses. Here we go. All right, now the question is, what is the inverse of 2 to the x? All right, so here, just think about this for a second. Inverse, this is y equals 2 to the x. All right, inverse is when we switch our x and y. So x equals 2 to the y. Now, our issue is we don't know how to get that y down. How do we get that y down from right there? All right. Well, we're going to use something called logs. All right. And let's think about this for a second. I'm going to create a table. All right. So here's our x. Here's our y. All right. Here, when x is, say, 0, I'm going to leave some space right here. So 2 to the 0, anything to the 0 power is 1. So 0, 1. All right. Now, if I plug 1 in, 2 to the first is 2. All right, if I plug 2 in for x, 2 to the second is 4. All right, 2 to the third is 8. And if I go a little bit higher, 2 to the fourth is 16, which is off the thing. But I can go backwards. If I do -1, 2 to the -1, remember, negative is when it goes down low. So 2 to the first goes down low. And so therefore, that's 1/2. All right. And if I keep going, it'll go like this. And it looks like this exponential like that. So there's our exponential. All right. So let's think about this for a second. Inverse, we switch our x and y. All right. Well, that's going to be 1/2 and -1. Here, 1 and 0. 2 and 1. 4 and 2. 8 and 3. So I go to x equals 8 and go up to y equals 3. And you see that it's doing something like this. These are the inverse. And if you remember inverses, inverses reflect over the line y equals x. All right, so they reflect over this right here. Okay, and you can tell those are reflections. Now this is 2 to the x. All right, but what is this of? All right, this is a logarithm. We can write this as log. And what we're going to do is, and you can think of it this way, 2x equals y. I'm going to flip that around for a second. All right. The base is going to come, the base of our exponent is going to be this little base on this log. All right. Of y equals x. Think of it as equaling the exponent. Okay. This right here is the graph of that. All right. So here, the inverse of an exponential function is a logarithmic, and it is a function because it passes the vertical line test, is a logarithmic function. And again, how I wrote that, I take the base and put it here. Okay. And then I say y. This is this is the same size as kind of log. This is a subscript right here, equals the exponent. All right. Sometimes I have a saying for this: first to the last equals the middle. All right. I think of this as the first, that's the middle, and that's the last. First raised to the last equals the middle, something like that. All right. Here, you can also do, teachers call it log loop. So 2y and then x. You look 2y and then x. And you're going to have to know how to go back and forth from exponential form to logarithmic and so forth. Okay, so here we go. We can write exponential equations in terms of logs. And that's what I just did a second ago. I'm going to write like 2 of these, and then I want you to pause it, see if you can write the next 2, and then see if you get them correct. Okay, here, this exponent, or that base of that exponent is going to go down here. And then 16 equals 4. So think a log loop. So 2, and then 16, and then 4. Okay. Now, this only works when you have the exponent on the left-hand side. So if it's not on the left, if it's written like this, 25 equals 5 squared, flip it around so it looks like this. All right, so let's do this again. Log base 5 of 25 equals 2. So 5, then 25, and then 2. Okay, do it again. If you want to, pause and do these next 2. All right, so here, log base 6 of 216 equals 3. Also listen to how I'm actually saying that this is said. All right, and this one is log base 4 of 2 equals 1/2. You go 4, 2, and then 1/2. All right, so we went from exponential form to logarithmic form. All right, we're going to go the other way around. We're going to go from logarithmic form to exponential form. Now, this one's going to make a little more sense. So here, 2, and remember, this is the exponent out here. So 2 to the 5th equals 32. And think about it. If I take my calculator and I actually plug this in, 2 raised to the 5th, does it equal 32? Yes. And I'll show you how to put logs in your calculator in just a second as well. All right, so let's do it again. Pause and see if you can do these 3 right here. We're taking 3 and we're going to raise it to the 3rd power, and then that should equal 27, and it does. You can check it on your calculator. All right, this right here. 4 to the 2nd equals 16. All right, and 25 to the 1/2 equals 5. All right, and I know that's a little funky to have the fraction as the exponent, but that can happen. All right. Now, here we go. Some more of them. Okay, we're going to go back and forth. Okay, this is an exponential form, so let's put it in log form. Log base 3 of 1 equals 0. All right, here, let's put this in exponential. So 4 to the 0 equals 1. All right, here, 7 to the 3rd equals 7 to the 3rd. Well, that makes sense, right? Should. Okay. 8 to the 4 equals 8 to the 4 again. So very similar to number 11. All right. Now, I know there's a log right here, but this is an exponential form. Okay. That's the exponent right here. So we're going to say log, and that's our base of 2 equals the exponent. So we took it from exponential form to logarithmic form. All right, same thing again. Log, this is our base on our exponent, so it's going to be our base on our log. And then we're going to say 4 equals the exponent right here. All right, and those are actually equal to one another. Okay, those work out. Now, I want you to look here and see if we can evaluate this for a second. All right. Do you notice anything where there's a 1 right here? Anytime we had a log where there's a 1, do you see how it equals 0? Okay, the reason is 5 to the 0 equals 1. Anything to the 0 power equals 1. So anytime you have a log, doesn't matter what the base is, and there's a 1, it equals 0. All right. Now, look at this one, number 16 right here. It looks very similar to 11 and 12. Here you have 7 and 7, 8 and 8. Anytime you have the base is the same number as that and you have this exponent, then it's just going to equal that exponent right there. So that just equals 2x. All right, we're not solving for x, we're just simplifying that. And then right here, number 17 is like 13 and 14. You've got it raised, but do you recognize that these two bases are the same right here? Okay, well here, this is just going to come out and reduce to x plus 2. All right, so we introduced logs. Now, as far as logs, you can stick them in our calculators. I'll show you here, and I'm going to show you on the Desmos as well. All right, here, as far as logs, I like to do this. I like to say alpha y equals, and I like to use this arrow right here, and I arrow over until I see number 5 log base. Okay, you can scroll down to number 5, or you can just hit 5 on your calculator. All right, and I can plug 1 in. I'll just plug in this one right here, 5 of 1. Okay, it comes out as 0. All right, I can even plug in this one right here. So I do alpha y equals, scroll over 1 till you see log base, hit number 5. And if I put 2 as the base and then 32, you're going to see it come out as 5. All right. Now, as far as Desmos, okay, if I'm plugging these in, let me go to Desmos right quick. All right. And I'm doing logs. So as far as log, you want to use this keyboard down here. Okay. And then you want to come over to functions. All right. And then you want to scroll. You may have to go a little slow. We're looking for log. All right. And there we go. Now we got 2 different logs. We got a log here and we got log base A. Now we'll talk about this one. Log with no base means that your base is actually 10. Okay. And we don't actually write the number 10. You can use this log. But here, anything with any other bases, that small subscript number, we want to hit it. Okay. And I'll plug in that 1, 2, and then we plugged in 32. And you see the answers coming out as 5. Okay, so again, let me do it again. You hit functions. If our log has a base, we want to hit this one right here. Okay, and then we had, all right, say 3, and we put 1. Remember, anything with 1 equals 0. And you see that it comes out as 0. All right, so let's go back. And let's solve some more equations here. All right, so here we go. Solve these equations using exponentials and or logarithms. All right, so here, if it's written in an exponential, we can actually use logs to solve this. Now, we could do what we did just a second ago with the warm-up. I mean, you put one side in, put the other side in, and just find their intersection. We can do that. But I do want you to be able to write this in log form. All right, when it's written like that, 10 is our exponent. All right, and then so 10, and then you say 10,000. Equals. Well, we just talked about how to put logs in. And if I put this into my calculator, I'm just going to use this calculator right here so I don't have to keep going back and forth. Alpha over y equals, scroll over 1, and we do number 5, and I put in 10, all right, and then 10,000 like that. And the answer comes out as 4. So here, x equals 4. And if I double check, doesn't 10 raised to the 4th power equal 10,000 right there? And it does. All right. So we can double check. Also, some of you may be looking at your calculators and you see this log button right here. Do you remember the log without the base in Desmos? That's actually, if you hit log, all right, remember what I just said about log base 10? Because there's a 10 right here, you can use the log button and actually just put in 10,000. If the base isn't 10, you cannot use that. Okay, so that's just a little snippet on that. Now, this is an exponential form, but do you see how there's a 5 out in front? Okay, I want to divide by 5 first. So 10 to the x equals 100. And we want to get to where all we have is the base raised to the power. That's it. Okay, now some of you may actually be able to think you can put this in log form, but some of you may be able to think, oh, wait a minute. 100 is 10 squared. If you can get these to be the same base, all right, instead of writing it in log form, all right, but you can write this in log form, log base 10 of 100, okay, and plug that in your calculator, you're going to get 2. But here, if you see that you can get the same base, just the exponents have to be equal to one another. So x equals 2. We actually could have done the same thing over here. This is 10 to the x, and then that's 10 to the 4th. So we see that x equals 4. All right. So see if we can get the same base here. Okay. So 10 x plus 3 equals, this is 10 to the 4th. Well, this time we have something extra up here in this exponent. We can still set them equal to one another. All right. Solve for x. So if I subtract 3, this time x equals 1. All right. I'm going to show you some with log form in just a second as well. Okay. If you cannot get the same base. All right. So let's look right here. Again, if you have anything multiplied out in front, you've got to divide by it first and get just the basically exponential part by itself. All right. The number raised to the exponent equals 100. Now I know I can get that to be the same base of 10 squared, just like I did in number 19 right here. But what if I don't know how to do that? Okay. Put it in log form. Log base 10 of 100 equals x. And we go to our calculator. All right. Alpha y equals, scroll over, and I'm going to do number 5. Okay. 10 and then 100. And I get 2. So x equals 2. All right. Now here, in some cases, you can't get the same base. So you're going to have to use logs. All right. Here, log base 10, because that base becomes the base of the log of 315 equals x. This is where it becomes really important to know how to write log form. Okay. So here, we're going to say alpha y equals. All right. I'll do some in Desmos in just a second. I'm just going to stick with this one for right now. Log base, I'm going to put 10 in, and then I'm going to put 315. Okay. Because the base is 10, I can use that log button if I want, but to be on the safe side, why don't you just use the other thing the same all the time? And here, I'm going to round it to 3 decimal places. 2.498. So x equals 2.498. All right, moving right along. Now, what do I have to do first with number 23? Got to get 10 to the x by itself. So if you said divide by 2, you are correct. So I get 400. All right, let's write this in log form. If you pause it, make sure you know how to do it by yourself. All right, log base 10 of 400 equals x. All right, so what if I want to do it in Desmos? I'm just going to plug it in there right quick. Okay, if I'm using Desmos, I go to function. I scroll down to where I see log base. So log base. Okay, I go put 10 in. And then I go put, and make sure you arrow over so you're inside this parentheses. If not, it's not going to work out. 400. Okay, and so round to 3 decimal places. So x equals 2.602. Now, let me show you this right here. So just keep in mind, and I'll just leave that right there. You could do this. You could say 2 times 10 raised to the x. This is the original function that's on the left-hand side. And then you have 800. Y equals 800. Okay. Now, here, I can go find it just like I did the warm-up. It's just you're searching up here for 800. Okay. I didn't have to search for that when I put it in log form. Do I get the same answer? I do. These are the same answer right here. So you can put one side of the equation in, the other side, and find their intersection if you would like. All right. But in some cases, you do need to know how to put it in log form. All right. Moving right along. Okay. Number 24, same idea. All right. Divide by 7 first. Okay. 10 to the 0.5x equals 10. All right. Now, if you want to put in log form, you can. Okay. Some of you may figure out that's to the first right there. Okay. But this equals 0.5x. So here, when I do this, log And if you want to use the log button, you can log and then 10, just because that base is 10. If it was like 3 or 4 or anything else, you can't do that. This equals 1 right here on this side, 0.5x. Now, I'm going to write this as a fraction. 1 equals 1/2 x. Now, think about how we get rid of the 1/2. You said multiply by 2. You are correct. 2 equals x. All right, let's keep going. 25. It's exponential. So let's write this as a log. Log base 10 of 4,000 equals 1.2x. All right, figure out what this is. Okay, so alpha y equals. All right, or because the base is 10, you can use that. All right, I'm going to put 10 and then 4,000. And I get this to be 3.602. I'm doing a video. I'll come up there in a second.
I gotta go to lunch, dude.
Got it. Equals 1.2x. All right. And then what I'm going to do is think about how to get x by itself. I divide by 1.2. Okay. So I'm going to just take this. You don't have to retype this out. If you just press the division and then say 1.2, it takes that answer and puts it right here. And now you've divided it. So x equals 3.00. And I'm going to, because that's a 7, I'm going to round it up to a 2 right there. All right, now 26 looks a little different. This time, do you see that it's not times? You got this 2. Now, this 2 is positive. So the first thing I'm going to do is I'm going to subtract it. Negative 4 to the x equals negative 64. Okay, now we haven't dealt with a negative right there yet. So you got to get rid of it. So divide by negative 1. So 4 to the x equals positive 64. Now, you can get this as the same base. If you can figure that out, it's 4 to the third. So x equals 3, or log form. Log base 4 of 64 equals x. So when I take my calculator, alpha y equals. All right, this time the base is not a 10, so you have to do it this way. Put a 4 and then do 64. And we figure out x equals 3. Okay. Now, again, you can take this and you can plug the entire equation into Desmos right here. You can say 2 minus 4 and then raised to the x. You do this a to the b and then x right here. And then press enter. And then y equals negative 62. All right. And you would find the intersection. Oh, there we go. Negative 62 is down here. Okay. And we see the answer is 3. And that's what we just got. But again, you have to know how to write it in log form. And that's what we are practicing today. All right. So moving right along. Okay. Here we can write this in log form. Log base 3 of 81. Go plug that into your calculator. All right. What are you getting? You should be getting 4. Now, this equals x minus 2. Now, I don't have x solved for yet, so what would I do? I would add 2. Okay, so 6 equals x, like that. All right. Now, for 28, you've got to get 4 to the x by itself. So the first thing we're going to do is divide by 12. Okay, don't distribute, please. Do not distribute. So this is 1 plus 4 to the x equals. All right, now your calculator actually reduces this for you. If you want to say it's 1.5, feel free to. If you want to say it, if you hit math, enter, this is 3/2. Okay, now subtract 1. All right, so if I minus 1, I get 1/2. So 4 to the x equals 1/2. Once you have this exponent by itself, be able to write it as a log. Log base 4 of 1/2 equals x. All right, so alpha y equals, scroll over, log base of 4 and then 1/2. And you can just say 1 divided by 2 right here, and that's fine. And what does it equal? X equals negative 0.5, but it's also negative 1/2. All right, now let's keep going. Okay, and it's okay for logs to equal negative numbers. Okay, I will tell you this. It is not okay to have a negative beside of a log right here. Okay, now keep going. We got to get this 11 to the x minus 8 by itself. So first add 5 before you put it in log form. So 11x minus 8 equals 59. Okay, put it in log form. Log base 11 of 59 equals x minus 8. All right. And then, so alpha y equals, or you can use Desmos, whatever's easier, 11 and then 59. Okay, I'm going to write this 1.700. I'm going to leave a couple of decimals equals x minus 8. Now, what do we do right here to get x by itself? If you said add 8, you are correct. So add 8. I'm just going to say plus 8 right here because it takes that answer and puts it there. So when I do that, 9.700, and we can leave it like that, or I can put a 4 as well. All right. And one last problem. The goal is, if you haven't figured it out by now, you've got to get this raised to the exponent by itself. So that's a positive 5. So I'm going to subtract 5. 2 to the x plus 1 equals 15. All right. Now, log form, base 2 of 15, because you're going 2, 15, and then equals the x plus 1. All right. Now, plug this in. Okay, alpha y equals, scroll, and you get log base 2 of 15. Okay, so this is 3.90689 equals x plus 1. And now look at what we do to solve for x. We would subtract 1. So minus 1 in my calculator, and I get 2.90689. If you want to, 2.90, we'll say 7 equals x right there. Okay. Now, again, you can take, now, if you don't have to get into log form, you don't have to necessarily do this. But if they ask you to get this in log form, here, they may actually just want the answer like this. When we subtract 1, instead of plugging that in, log base 2 of 15, and then it's just minus 1 equals x. And they want you to represent it like that. All right. Whoops. Hold on. You can't see it. There you go. Like this. Now, I'm not subtracting the 1 right here. All of this goes together. I'm not subtracting it from the 15. Same thing here. We would just add 8. So log base 11 of 59 plus 8. All of that goes together. Don't add the 8 to the 59 equals x. So sometimes they may just want it represented like that as well. All right. Know how to write, go back and forth from exponential to log or log to exponential, and that can help you solve equations. I will plug this one just to recall into Desmos right quick so that we can see it. If all you want is the decimal for it, feel free, 5 plus 2 raised to the x plus 1. Oops. By the way, if in the exponent spot, you have to put parentheses and then plus 1 if you're using Desmos like that in parentheses. Otherwise, the 1 just jumps back down. All right. And then on the other side, it equals 20. So I'm going to put y equals 20. All right. I'm going to zoom and you go find the intersection. And this is the answer that we just got for number 30. So if you just want the decimal, you can just plug it in this way. But you do have to know how to write things in log form. And remember that exponentials and logs are inverses of one another.